let's do this last problem. Shouldn't take me that long to do it. Okay, so let's read it. A wood slab with thickness of 0.05 meters is subjected to a heat flux of 40 watts per meter square. The left and right surface temperatures of the wood slab are kept at constant temperature of 40 degrees Celsius and 20 degrees Celsius respectively. What is the thermoconductivity of the wood slab? So thermoconductivity, that is what we're looking for. Okay, in this case that would be K. Let's make our table where we want to put the knowns and unknowns. And that way we can get started with this. Okay, well, we do know that thickness is 0.0. Let me do this one again. Okay, let's zoom in a little more. So my thickness is equal to 0.05 meters. Okay, heat flux is equal to 40 watts divided by meter square. I'm also given my delta T's. So if I convert that into kelvins and I subtract them, I'm still going to get 20 kelvins. Just like if I subtract 40 degrees Celsius and 20 degrees Celsius and subtract them, I get 20 degrees Celsius, right? So I'm just gonna put as my delta T as 20 kelvins. Okay. Again, you can do this 40 plus 273, which is equal to 313. Then you can do the 20 degrees Celsius plus 273. You want to add 273 in order to go from degrees Celsius to kelvins. Okay, the formula is this one: TK is equal to the temperature in degrees Celsius plus 273. If you add 273 to this temperature in Celsius, your final units will be in kelvins. So if I do that, I'm gonna get 293. So if I subtract 313 minus 293, what I get is 20 kelvins. Okay. Interesting. That doesn't seem quite right. Let me just double check. Minus 293. Yeah, 20 degrees. I don't know why it looked a bit weird. Anyways, so that's how I got my 20 kelvins. Okay. What I'm looking for is thermal conductivity. Now, here's the thing. I know I have this formula. Q dot is equal to thermal conductivity times the area times the change in temperature over the thickness. I do know I have the change in temperature. This is what I'm looking for. I know the thickness. I shouldn't have put that. This is what I'm looking for, question mark. But I don't have the area. I have no way to find the area. Nor do I know the rate of energy transfer. Okay? But I do know that heat flux is actually equal to Q dot, or the rate of energy transfer over area. So what I can do is I can substitute this Q dot with this formula. Okay, so what I'm gonna do, I'm gonna have heat flux is equal to Q dot over area. I do know that Q dot is equal to that. So I'm gonna have thermal conductivity times the area times the change in temperature, all divided by the thickness divided by this area. Okay, I know that this area is over 1. Okay, let me simplify this. Thermal conductivity times the area times the change in temperature divided by L divided by the area over 1, which transforms into that. I do know that I cannot divide fractions. I have this fraction being divided by this fraction. In order to fix that, I need to convert this division symbol into multiplication. If I do that, then I do the reciprocal of a over 1, which is just flipping that fraction over. So that's going to be 1 over a, which in turn is just going to be thermal conductivity, area, change in temperature, all over thickness divided by area. So this is where the areas go away. They just cancel out. So then what I end up with is just this. The heat flux is equal to thermal conductivity times the change in temperature over thickness. Okay, and what I'm looking for is this one right here. All right, I can start plugging in values. I usually like to solve my variables. I do know that this k is what I'm looking for. I want to isolate that k. I want to leave that by itself on that side of the equation. In order for me to do that, I need to multiply this side of the equation by the reciprocal of this. I want to cancel the L, so I need to put that on the top. I also want to cancel the delta T, so I need to put that on the denominator. That way this cancels out with that one, and this cancels out with that. Now, here's the thing. Whenever I do something like this, I know that wherever I do on one side of the equation, I have to do it on the other side of the equation. Therefore, I need to multiply this side of the equation by the same thing. So at the end of the day, I'm going to end up with, oh, this is over 1 by the way. I'm going to end up with L times Q dot, all divided by the change in temperature, which is going to be given, or which is going to give me my thermal conductivity. At this point, all I have to do is just plug in the values that I'm given. Okay, so let me rewrite it. So thermal conductivity, thickness was 0.05 meters, 0.05 meters. Heat flux was given to me as 40, let me just double check, yeah, watts divided by meters square. Change in temperature was 20 kelvins. Now I can start canceling my units. So this meter is gonna cancel with one of that. Okay. So then I'm gonna end up with this here. I am going to multiply 0.05 times 40, whatever I get, I divide by 20, so I'm gonna end up with 0.1 watts divided by meter divided by kelvins. Again, this is over 1, right? If I want to fix this, I have watts divided by meter, which are divided by kelvins over 1. So watts divided by meter times 1 over Kelvin. So essentially the same procedure on the top. So watts divided by meter Kelvin. So my final answer is going to be 0.1 watts divided by meter Kelvin. Okay, and that's it. I hope this helps.